let's do some graphing. Let's graph some trigonometric functions. And the first two I want to graph is just the plain sine function, the sine of x, and the second one, the cosine of x. Really the two main important functions. And then we're looking at transformations of those functions, periods, amplitudes, the whole 9 yards. But again, first, let's look at some plain sine and cosine function. Now, to graph them, what we really need are 5 key points. And where do those 5 key points come from? Well, I already graphed it here. They come from the unit circle. And we're graphing angles and the corresponding y-value. So they come from the unit circle at 0. We have 1, 0. Then we go to pi over 2. Then we have pi, 3 pi over 2, and 1 full revolution around the circle. Of course, we end up at 2 pi. So these are our x values, our main key points for graphing any kind of trig functions. So let me just list them here. Here's x, here's y. So we go 0. Then pi over 2, what happens at pi over 2? Then we go to pi, 3 pi over 2, and 2 pi. 1, 2, 3, 4, 5. 5 key points. Now, what did we say in class? The sine function is defined as the y-coordinate of our ordered pairs. So that's an easy way to find, if you look at the unit circle, an easy way to find the corresponding y-values. There is a pattern. With a sine function, we start at 0, then we go up to 1, then we go back down to 0, then we go further down to -1, and then we come back up to 0. These are our y-coordinates, and you see them right here in the unit circle. Okay, so let's graph. So here we have 0. Let's make this pi over 2. Pi, 3 pi over 2, and 2 pi. Okay, what are the y-values? Well, the domain of a sine and a cosine function, the plane cosine function, you can see we go at the highest to 1 or to -1. And a sine function always starts at the origin. A sine function is an odd function. Remember that? 0, 0, then pi over 2, we go to 1, then we go back down to 0, then we go further down to -1, and we come back up to 0. And if we, beautiful, here you go, I almost missed it, here you go. That is what is called one period of the sine function. Now, a sine function really does never end, because a sine function, I could continue on and start a new period. So if I'm going to add another pi over 2 to it, I'm at 2 and 1/2, 5/2 pi. So then I would go back up to 1, then I come back down to 3 pi to 0, and I have no more room, so it keeps going on. And then, of course, you would go to -1, and at 4 pi, you would go back to 0. So this is what is called a period. One period goes up, down, and back to 0. And of course, I can extend that to the negative side. I can have -pi over 2, -pi, and so forth. So I'm going down to -1, going back up. And then if I had more room, I would go further on with this function. Now, what we have here, what we are graphing, are the intercepts and then the maximum and the minimum. So where the graph crosses the x-axis, these are our x-intercepts. right here, intercepts, x-intercepts, and at pi over 2 we have a maximum, and at 3 pi over 2 we have a minimum. And that is the plane sine function. It starts at 0 and it ends up at 2 pi, and that's one period. If we do some transformations and shifting, then of course the period may change. Now let's take a look at a cosine. Okay, at a cosine, the 5 key points are still the same. X, y, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now again, that is something you need to memorize. That has to come like naturally to you. Now, if we look at the unit circle, the cosine is defined as the x-coordinates of our ordered pair. So if we start at 0, the cosine starts at 1. Then we go to 0. Then we go to negative 1. 3 pi over 2 is 0. And then 2 pi, 1 full revolution is 1 again. So how does that look? Pi over 2, pi, 3 pi over 2, and 2 pi. These are, and here's 0, of course, these are our key points. We go from 1 to negative 1. So the cosine starts at 0, 1, then it goes to 0, then it goes further down to negative 1, then it goes back up to 0, and we end up at 1. Somebody once told me it looks like a seagull. There you go. This is one period of the cosine. And the period, of course, is 2 pi times, because that's one full revolution around the circle. If we add another pi, then 5 pi over 2, then again we would go to 0, and then further down, the same on the left-hand side, negative pi over 2, negative pi. We go through 0, we go further down to negative 1, and then we have negative 3 pi over 2. Let's see. And then we have negative 2 pi. I can get, beautiful. Here you go. This is, to the left, is another full period of the cosine. So here we have we're starting off with the maximum. And here's our minimum, and of course you can see the x-intercepts are right here at pi over 2 and at 3 pi over 2. Now, plane cosine and sine functions. What else do we need to know? The range of both of them is from negative 1 to 1. The domain, of course, is from negative infinity to infinity. What else? We have a cosine function. The cosine function is an even function. So the cosine function is an even function. What does that mean? That means if we have the cosine of x, for example, of pi, which is negative 1, the cosine of negative pi is also negative 1. So the cosine of x is exactly the same as the cosine of negative x, even function. The sine function, of course, domain and range are the same, but one more, the sine function is an odd function. Odd functions are symmetric with respect to the origin. So you see how the sine function goes through the origin. Even functions are symmetric with respect to the y-axis. So if we were to put this together, we would have the mirror image. Now, what does that mean for the sine function? The sine of x, let's say of pi over 2, is a positive 1, while the sine of negative x is a negative 1. So the sine of x is the same as the negative sine of negative x. Here you go. Odd and even functions. That's beautiful graphs of sine and cosine.